Today we're going to be talking about the science behind roller coasters. First, here's a short roller coaster ride. As you're watching, think about how this roller coaster is moving and how you think it might work. One thing you might notice, it's being dragged up the hill right now by some chains that you see in the middle there. But there is no engine on a roller coaster, so how is it actually getting up and down the hills? Really easily with just simple materials at your own house. Physics is the branch of science that has to do with how roller coasters work, and it's the study of how objects, force, and energy interact with each other. Force is a push or a pull, and it can change something's shape, its speed, and its movement. An example of force would be if you pushed your little brother or sister on a swing. You pushed them and you changed their speed and you made them move. In a roller coaster, one of the forces is the roller coaster being pulled up the hill by the chain that you saw. Speed is how fast an object moves. It can be calculated by distance divided by time. An easy way to think about this is if you ran 100 feet in 10 seconds, 100 divided by 10 would be 10 feet per second. Friction is the resistance of motion when one object rubs against another, and you've probably experienced this a lot without realizing it. If you've ever ridden a scooter and pressed down hard on the brake, that brake works by creating friction against the wheel and stopping it. The scooter's brake, because of all the friction, will actually also build up heat, and if you're like me, you can actually burn your foot if you don't wear your shoes and try to brake the scooter. Gravity is the force by which a large object, like our Earth, pulls objects towards its center. It's why we don't go floating off into space, and it's also why roller coasters are pulled down the hills that they're on. Potential energy is one of the forms of energy that you see with roller coasters, and it's energy that is stored and ready to be used. Sometimes it's called positional energy. This energy you can think of as being at the top of a hill on your bike. You haven't moved yet, you haven't started moving, but you're ready to go. Kinetic energy is the energy an object has when it is in motion. So unlike potential energy, you're not sitting at the top of the hill anymore, you're flying down it. That's your kinetic energy. Anything that is in motion has kinetic energy. So this is something called a simulation, and because we can't go to a roller coaster park right now, we can still experiment with and model things using a digital simulation. So this one is pretty cool because as you watch the roller coaster, it gives you a graph, a little pie graph at the top of how much kinetic energy versus potential energy the roller coaster has at any moment. As you can see, as it moves up the hill, it gains more and more potential energy that it has stored up. And then as it moves down the hill, as it's in motion, it then has kinetic energy. Here's a similar simulation, except for this one uses cars, and you're supposed to try to not break the egg. You can change the height of the hill, and you can even change the mass of the cars on the side, and then launch your car. Oh, I broke it. You press the little arrow button to go ahead and reset it, and then you can try it again. So in order to not break the egg, I'm going to try to add a second hill, and maybe that'll slow it down some. Oh, nope. So you can go ahead and keep experimenting, and you can add up to 3 hills to try to get it to touch the egg but not break it. So I'm going to adjust it and then see if my car doesn't have quite as much energy, if it'll not break the egg. So I had to remove some of the energy that my car had in order to not break the egg. Oh, this one doesn't even have enough energy to get over that first hill. The only supplies you need are paper, scissors, and tape, and a ruler if you have one. For most of the pieces, what you're going to need is one normal sized piece of paper, and use thicker paper if you have it. Go ahead and fold it into thirds. This can be tricky at first, but you get the hang of it pretty quick. Just kind of experiment and crease it until you get at least mostly thirds. Doesn't have to be perfect. Once you have them in thirds, you're ready for cutting, and go ahead and cut out the thirds along the crease that you made. We're going to use these pieces for different parts of our roller coaster. With one of your thirds, go ahead and take it, and you're going to crease it to make this, just a basic ramp. Here's a curve, here's another kind of curve, and here's a support, and this is how you're going to make your roller coaster stand up and look cool. Here's a tiny one that I made. Basically, you do the exact same thing, but you cut out fourths instead of thirds. So let's go ahead and we're going to fold this in thirds. It can be a little bit difficult to crease it. And fold the other side into the crease that you made. And voila! You have thirds and a basic ramp to roll your marble down. Now, if you only have gigantic marbles at your house, you're going to want to make your ramps a little bit wider. Mine is for pretty small marbles. Now, the next one we're going to cut out, we're going to make a support. We're going to make a skinny support instead of the thicker support you saw earlier. So you cut out your third again and fold it, this time all the way in half, because we want fourths this time, so we're going to fold it in half once. Fold the corners back into the middle to make 4 parts. Now, what's neat about this is we can kind of roll it up. See the 4 lines? We can kind of roll it up, and we have a nice strong support. And we're just going to go ahead and put some tape on each part to keep it together. Doesn't need a ton of tape. My tape is not very sticky though, so if you need more, just use as much as you think you need to keep it together. I did not try out a glue stick, but a glue stick might work if you gave it enough time to dry. So you see I put one tape in the middle and one tape on each end. I did not try to tape the whole thing because I didn't want to waste all my tape too fast. Now I'm going to cut it, and this is how you make it able to be taped or glued down to your base so that the support will stand up straight. And you want to cut it about an inch up. If you cut them all different sizes and do not cut them the same, it will tilt. And I had this problem a lot with my practice roller coasters that I made. And now you can see that you can easily tape it down to your base. So here I'm using the big version with a whole sheet of paper, not the mini version of the support. And you can see that I already have the tabs out at the bottom, and I can easily tape this down. Here I'm taping it to a table, but it's better to have a piece of cardboard or something to tape it on, because sometimes tape can rip stuff that you don't want it to be ripped or leave a gross residue on your table or counter. So here you can see it stands up nice and straight. And now we can take one of the ramps that we've already made, and you're going to make a cut on each side, bend it back, and that's what we're going to stick inside the support and tape so that the ramp will be secured on it. So there you can go, you can see inside, and all we're going to do is stick a piece of tape in there. And now we have a ramp that we can add another support to, and voila. So now I'm just going to stick this tiny support that I have left over underneath, and this is the basics of building your paper roller coaster. It's just putting ramps and supports at different places until you get the kind of coaster that you want at the speed that you want. So here I'm building a bigger coaster, and for that I need a lot of supports and I need them to stick together. To make big supports stick together, you cut one flap out and then you stick the next support in so that the flap is on the outside and the rest of it is on the inside. And then all you have left to do is tape it. You could repeat these steps until you have like a 10-foot coaster if you had enough room and enough paper. But I'm only making one that's about 3 feet tall. To build a curved piece, all you need is a normal ramp, and then you need to cut about 1/2 inch slits all the way down to the end of it. Once you have that part, what we're going to do is we're going to continue cutting those slits straight over to the other crease. Be very careful that you don't cut through the whole thing. Basically, we're cutting 2/3 slits straight to the other crease. This is going to allow it to curve in whatever way we want it to. It can be hard to hold the curve in the shape that you want and tape it, so this might be a good time to get some help with getting this part taped up. So here's my very basic coaster, and it's just basically a few ramps and a curve. And I'm gonna test it out with a few marbles just to make sure everything's okay. You can see that I made a stopping ramp at the end by just putting a little block at the end so my marbles don't roll everywhere. And it works pretty well, but I'd like to make it a little cooler, so I'm gonna add to the end, just like a real roller coaster, a loop and we can see if it has enough kinetic energy to actually go all the way through the loop. Gonna go upside down and back out. Let's see. And the test works.
This is CMSD.
I am. Yo soy.
I am Cleveland's public schools.
Hi, I'm Mrs. Kenny.
And I'm Mrs. Lynchbaugh.
And we both are 5th grade teachers at Douglas MacArthur Girls Leadership Academy.
So this morning we're going to talk about inferencing. So first of all, what do you think an inference is?
I know! It's an investigation!
Well, it's kind of like an investigation. So an inference is a kind of like an educated guess based off of what you already know, so your background knowledge, and what you're observing happening or what you're seeing happening in front of you. So we're going to practice making some inferences. What do you think? Okay, great. So I'm going to read you a sentence and you're going to make an inference based off of what you know and based off of what I'm reading in the sentence. So here we go. Charlie grabbed the clippers and scissors and got to work. So let's think. What can we infer based off of that sentence? Let's think about what we already know.
Well, we know that scissors cut.
They do.
And we know that clippers are used to shave heads.
And if he got to work, what do you think that he's doing?
I can infer. Can you infer? That's right. He's a
barber or a hairstylist. Very good. All right, let's try another one. We couldn't believe our eyes. Trees were uprooted and homes were missing roof shingles. So again, let's think about what we already know.
What can you infer?
All right. So we couldn't believe our eyes. Trees were uprooted, so that means they were up out of the ground.
Well, I can infer that something big had to pull them out of the
Right.
ground. What else?
They were missing roof shingles. So if something was that powerful to pull roof shingles off the top of a house, what do you think?
I think, and I bet you can infer, that a big storm or a tornado happened.
Yes, I think that's great. That's a great inference to make. Great, now that we've practiced our inferences, we're gonna make some inferences about these balls and what would happen if we were to roll them down a ramp using potential energy, kinetic energy, and mass. So first off, potential energy is that stored energy. It's energy that is stored in an object right before motion happens.
Kinetic energy is the energy that is used during motion.
And then mass is all the matter in an object, so kind of like the weight of an object, and it's usually measured in grams or kilograms. So, I have here with me a big heavy bowling ball.
I have a basketball. It's not very heavy.
And then we also have a tennis ball, which is pretty light. So if we were to roll these objects down a ramp, we're gonna investigate them, okay. If we were to if we were to roll these down a ramp, what do you think would happen based off the potential energy, the kinetic energy, and the masses of these objects? Remember, we said this one's really heavy.
This one is just a little bit heavier
And
or
this
lighter.
one's super, super light. So let's think about what would happen if we were to roll these down a ramp and make some inferences.
I can infer that the heavier ball will go further because it's heavier.
Really heavy. I can infer that this light one wouldn't go as far because it's super, super light and its mass is not as much, it doesn't have as much mass to it.
And since the basketball, it has mass in between the bowling ball and the tennis ball, it would probably go in between the two of them. Let's wait and see if our inference is correct. All right, so now we're gonna do some investigation work. We are going to use sidewalk chalk,
Some yardsticks,
and a board that we found in my garage as our ramp. And we also have our different size masses of balls. So the first thing we're gonna do is measure out our yards. Remember, 3 feet make 1 yard. And how many inches are in 3 feet? 1 yard? That would be, that's right, 36.
All right, so as we get started, remember those inferences that we made earlier on about the balls and what we think would happen based off the potential energy, kinetic energy, and the masses of them.
So the first ball that we're going to use is the tennis ball. If you remember, it has the least amount of mass, but we're going to start it at the same position so that all the balls have the same potential energy. Once the ball starts moving, the kinetic energy kicks in. So let's see where it's going to end up.
All right, so I'll mark that TB for tennis ball and we'll measure it later.
Our next ball is our trusty basketball. This was the ball that was in between masses of the tennis ball and our bowling ball. We put it in the same position so it has the same potential energy.
I stopped it because the wind was applying an external force and it started to veer off. So sometimes that happens. We're just going to mark it on the line where it starts to veer off at.
This is a heavy bowling ball. The mass is so much greater than our tennis ball. Same position, same potential energy right now.
Okay, so as we can see, the mass of an object does indeed affect the distance that it rolls based off of its kinetic energy.
The tennis ball with the least amount of mass, the basketball, and the bowling ball with the greatest amount of mass went the furthest distance.
Okay, now it's time to look at the distance of our balls and measure the distances of them.
As you can see, our tennis ball traveled a little over 4 yards. We drew out our yard men so you could see that we have 1, 2, 3, and 4 yards that it traveled. But since our tennis ball traveled a little bit over 4 yards, we're going to round to the closest yard.
We can see that our tennis ball didn't quite make it halfway. It was less than halfway to the next yard, so we're going to round down to 4 yards.
So we're going to mark on our board that our tennis ball traveled 4 yards. When we look at our basketball, we see that it didn't quite make it to our 5th yard. So when we round, since it's closer to 5 than 4, we're going to say that it traveled 5 yards. When we come over to our bowling ball was almost 6 yards. So when we round, it's closest to the 6 than it is to the 5. So our bowling ball traveled 6 yards.
All right, parents, today we're gonna make a yard man. So if you could go grab some materials while your kids are watching, they can follow along with us. First, you'll need some paper. Any kind of paper is fine. We have construction paper, but computer paper, anything you have at home.
Scissors.
Glue. If you don't have glue, you could also use tape. It works the same way.
And a writing utensil, marker, crayon, pencil, anything would work. All right, so we're gonna make a yard man. Within our yard man, we have 3 feet. 1, 2, 3. And each foot has 12 little fingers. Those little fingers represent the inches that are in each foot. Altogether, we have 3 feet in 1 yard and 12 plus 12 plus 12
Or 12 times 3.
equals 36
36
inches.
All right, we're gonna start off with cutting the body of our yard man. So that's the big Y in the middle. We're gonna show you 2 different ways of how to cut your body. So if you're gonna do it this way, you have to fold your paper hot dog style. Make sure you make the crease in the middle. And then, starting on the crease side, you're gonna draw half of a Y. So I'll draw it real quick and then I'll show you. So it'll look like this. Then, when you cut it out, it'll look just like a Y.
I'm just gonna freehand it. I have my paper and I have my writing utensil. And I'm just going to do bubble letter of a Y. Ta-da! All right, so now we're gonna make our 3 feet. And the best way to do that is to fold our paper into thirds. Take one side, fold it in, take the other side, fold it in.
And it doesn't have to be perfect.
That's right. Now, take your writing utensil and draw whatever silly shape you want for your feet. I'm just gonna draw kind of like a circle-ish weird shape. Now, I cut all the way around. It doesn't have to be perfect because our yard man is kind of a silly guy. And when I'm finished, I have 1 and 2 and 3. My next step, I want to label them. 1, 2, and 3. We're labeling because there are 3 feet and 1 yard. From here, we are going to glue them onto our yard man or tape. It doesn't matter. I have glue here, so I'm going to use some glue. I put it on the bottom just a little bit on the front, and I slide it underneath and push it down. Some more glue, slide it underneath, and push it down. Remember, a little bit of glue goes a long way. And there we have our 3 feet and 1 yard. The next step, we are going to do our inches. We have 12 inches in 1 foot. So each foot needs 12 little pieces. We have our pieces already cut out.
And remember, we said that 12 times 3, or 12 plus 12 plus 12, is 36. So that means you're going to need 36 little toes.
All together. But make sure you are only placing 12 on each foot. So let's go ahead and do that. All right, so once you have all 36 of your little fingers and toes on your yard man, you can add eyes, silly eyes,
A mouth.
and don't forget your label. As you see, we took our measurements that we did outside and we converted them from yards to feet and inches. Who remembers what it means to convert?
That's right. It means to change.
So when we're changing a unit of measure from big to small, what do we do?
Well, let's think. Horse
Is a very big animal.
and a fly.
Is very small.
So, horse to fly
Horse to fly.
means you multiply.
We multiply. And if we're going from a smaller unit to a bigger unit,
That's going from a fly, which is a smaller animal.
to a horse, which is a bigger animal,
So,
we
fly to horse. Divide, of course.
we divide, of course.
So let's look at our measurements, and now we're going to convert them, and we need to think about if we're going bigger to smaller or smaller to bigger.
So let's take a look. We have yards. We use a yardstick to measure yards. Is this bigger or smaller than a ruler? A ruler has 1 foot or 12 inches.
If you said smaller, you're right. So we're going from bigger to smaller. So if you remember, horse, which is bigger, to fly, that means you multiply. So that we have 6 yards. Now we're multiplying. What are we going to multiply 6 by to figure out how many feet are in 6 yards?
What can you infer?
That's right. There are 3 feet in 1 yard. That means we're going to multiply 6 times 3. Now 6 times 3 is,
You're right.
18. Very good. So 6 yards equals 18 feet. Our bowling ball traveled 6 yards and also went 18 feet because they're equivalent. So that means that they're equal.
We have a smaller unit, smaller number for yards, and a bigger number for our feet because it's going to take more of these rulers to measure out how far our bowling ball went. All right, so let's take a look at our basketball. We want to take our basketball from 15 feet to how many inches? 15 feet equals how many inches? Are we going from a bigger unit of measure to a smaller unit of measure, or a smaller unit of measure to a bigger unit of measure? What can you infer?
That's right. If you said bigger to smaller, you're correct.
So if we go from bigger to smaller, or from horse to fly, we multiply.
Very good. So let's think about what we're going to multiply by. Well, if we take a look at our ruler, there are 12 inches in a foot. So that means if you said that we're going to multiply 15 times 12, you were correct.
So now we're going to take 15 and multiply it by 12. We have 15 times 12. The first step when we multiply, we go straight up. So 2 times 5 is, that's right, 10. Put down the 0, carry your 1. The next step, we would do 2 times 1 is 2, but don't forget to add what you carried over. So that would be 3. The next step is to make sure that you add your 0. I always like to put a little smiley face so I don't forget. Then I multiply 1 times 5 is 5. 1 times 1 is 1. Our last step is we add them up. 0 plus 0, 0. 3 plus 5 is 8. 0 plus 1 is 1. So our answer is 15 feet equals 180 inches.
Okay, lastly, we're going to take a look at how far a tennis ball rolled. Remember, we already converted this for you or changed it. It traveled 144 inches. Now, we want to try and change or convert that into feet. Remember, are we going from smaller to larger or larger to smaller? Take a minute to think about it. If you said smaller to larger, you're correct, because we're going from inches, which is a smaller unit, to feet, which is a bigger unit. So fly, smaller, to horse, you divide, of course. Now let's take a look and think about what are we going to divide this 144 by to get us feet? Well, there are 12 inches in a foot. So if you thought that we would divide 144 by 12, you're correct.
12 into 144. How many times does 12 go into 1? It doesn't. So we got to move it on over. How many times does 12 go into 14? That's right, 1 time. 1 times 12 is 12. Subtract it out. 14 minus 12 is 2. You bring it on down and bring it on back. How many times does 12 go into 24? That's right, 2 times. 2 times 12 is 24. Subtract it out. There's no remainder, so our answer is 12 feet. So as you remember, looking back on our lesson, we did a little bit of inferencing today.
We learned about conversions.
And we learned about kinetic and potential energy using masses.
We hope you had fun.
Catch you later!
This is CMSD.
I am. Yo soy.
I am Cleveland's public schools.
Potential, kinetic, potential, kinetic, potential, kinetic, potential, kinetic. Potential, kinetic, potential, potential, kinetic, Potential. Kinetic. Potential. Kinetic. Potential. Potential. Kinetic. Potential. Potential. Kinetic. The principles of physical education, FIT, F-I-T-T. The F stands for frequency. How often should you get your exercise? The I stands for intensity. How hard or how easy your workout is. Your T is time. Your activity should be at least 60 minutes every single day. And T is type, the type of activity that you choose to do. There are 5 different components. Today we're going to talk about 4 of them. The first is cardiovascular endurance. When you hear the word cardiovascular, that means it has to do with your heart. Cardiovascular endurance, increasing your heart rate over an extended period of time. The second is muscular endurance, the ability for your muscles to repeat that action over and over and over. Muscular strength, that's power. Sometimes we can gain that power by lifting weights, or sometimes we can just get that power by using our own body. Squats, push-ups, lunges, and the last component is flexibility. Flexibility, we become more flexible by stretching. We stretch, the more limber our bodies become, and we are better able to move in many different ways. You can gain strength just by lifting your own body weight. So when we do a push-up, place my hands shoulder width apart, my legs are extended, and my back is straight. When I'm going to do a push-up, I'm going to bend my elbows and extend back up. Bend my elbows and extend back up. Now, for some people, a push-up might be a little bit difficult, and so we can do what's called a modified push-up. I can use a railing, I can use a wall. I'm going to keep my feet about a yard away from the wall or the railing. I'm going to place my hands shoulder width apart. My back is straight. I'm going to do just like I did. Bend and extend. Bend and extend. Bend and extend. The more push-ups we do, the more power we gain. So I said earlier that a cardiovascular activity is one that it increases our heart rate. Something as simple as a step. We're going to do a 30-second challenge. You're going to stand next to your object and see who can up, up, down, down. That is 1. Up, up, down, down. That is 2. Let's see how many we can get in 30 seconds. Go. Stop. Jump roping is a very good cardiovascular exercise. It is a whole body exercise. We use our upper body, our arms and our shoulders to turn the rope, and our lower body to jump. There are so many different ways that we can jump rope. Can jump on 2 feet. Can jump on 1 foot. Can alternate. We can jump backwards. And we could do tricks. Jump roping really gets that heart beating. Another exercise activity that we can do to build power and strength in our body are sit-ups. Now our sit-ups work on our core, they work on our abdominal muscles as well as our posture. I can cross my arms, I can put my hands on my shoulders, I can lay down, and I can sit up. If I can do a lot of sit-ups at one time, I might want to increase the intensity by adding weights. I have a 6-pound, what they call a medicine ball. I can lay down and sit up. Building my core strength. Flexibility allows your body to bend and move in many different ways. As some of you might have done in your physical education classes, the sit and reach test. Are you able to reach all the way down and touch your toes? I can extend one leg out in front while bending and placing my foot next to my leg that is extended. Can you reach and touch your toe? Can you reach with both hands and touch your toe? If you're really flexible, you can touch your nose all the way down to your knee. When I extend my right leg, I also want to do the same thing on my left. So I extend my left, I bend my right with my foot next to my leg, not under it. I can reach with two hands. I want to hold that stretch for about 12 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Oh, that feels so much better. Staying flexible is really important. So you need to get some flexibility exercises in every single day. Potential, kinetic, potential, kinetic.
This is CMSD.
I am. Yo soy.
I am Cleveland's public schools.
Hello everyone, my name is Jason Levy and I'm the music teacher from Campus International School. Today I'd like to share a song with you that I learned from another music teacher named Miss Lutz in New York. Here's how it goes. Dum dum da 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 dum dum da da dum dum da 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 dum dum da 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 dum dum dum. Very good. I bet you're going to pick this song up very, very quickly because there aren't very many words. So just dum dum and da 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 da. And you'll probably notice that every time I say the word dum dum, I'm padding. So I'm going to teach this to you in little sections. I'm going to sing it the first time, and then you are going to echo after me and sing it the second time. So I'll leave some space for you. Dum dum da 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 dum dum da da. Excellent. We'll try that one more time. Dum dum da 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 dum dum da da. Very, very good. Here's the second part. Dum dum da 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 dum dum, da, 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 da. So I'm going to sing it one time. You're going to echo after me. Dum, dum, da, 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 dum, dum, da, 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 da. Very good. So when we put those two parts together, it sounds like this. I'll sing it the first time. You echo after me. Dum dum da 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 dum dum da da dum dum da 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 dum dum da da da. Very good. And I love how some of you are even patting with me as we sing. So here's how the last part of the song goes. And it's very similar to the beginning. So I'm just going to do the whole thing and then you can echo after me. Dum dum da 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 dum dum da da dum dum da 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 dum dum dum. Exactly right. So many of you noticed that at the very end, the only difference is that there's a dum dum dum. So let's try the whole song together. 1, 2, here we go. Dum dum da 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 dum dum da da dum dum da 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 dum dum da 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 dum dum dum. So there are some more motions to the song, but I'm going to do those sitting down so you guys can see them a little bit better. So we've been patting on the dum-dums, and we're going to add a little bit more to it. So we've been patting, and then the next motion is we're going to go off to the side. So you're going to have one hand on your knee, and then the other hand is going to be off to the side. So that's going to look like this. Dum dum da 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 dum dum da da dum dum da 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 dum dum da 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 dum dum dum. Excellent. And then we end with the 3 dum dum dums. So let's try that one again. Dum dum da 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 dum dum da da dum dum da 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 dum dum da 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 dum dum dum. So that's the one that I call side because we go off to the side. Now this is the one that I call cross, and it starts off with the same pat, but then we cross our hands. So we're still on our knees, but we cross our hands. And then we pat again, and then we go out so our hands aren't on our knees at all. So it looks like this. Try it with me. 1, 2, here we go. Dum dum da 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 dum dum da da dum dum da 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 dum dum da 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 dum dum dum. We always end with those 3 pats on the dum dum dum. Very, very good. So now you know the side, and you know the cross. And this last one that I'm going to teach you today is called the hand jive. And it looks like this. Dum dum da 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 dum dum da da dum dum da 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 dum dum da 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 dum dum dum. So the hand jive is a few more motions. So it starts with a pat, then it goes to 2 claps. Then we do some scissors, and scissors on the other side. Then we do some mash, and we mash on the other side. And then we end it with our hitchhike over the shoulder. So let's try that one with me. 1, 2, hand jive, go. Dum dum da 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 dum dum da da dum dum da 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 dum dum da 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 dum dum dum. Excellent job. So on our dum dum song, you've learned the pat pat off to the side. You've learned the pat pat cross pattern. You've also learned the hand jive. And these patterns are so much fun because if you have a brother or a sister or a friend or your parents that you could do this with, if they're sitting next to you and you pat and go off to the side, then one of your hands is patting on their knee, or when you do the pat and you go out, then both of your hands are on your friends or your parents' knees. And this game song can be a lot of fun. So my name's Mr. Levy. It's been so much fun teaching this song, and I hope to see you guys soon. Thanks. Bye.